Okay, jumping in for part 3, studio time. Studio time is where your learners are going to engage with a partner, working collaboratively, creatively. They're going to have to cooperate. One marker, two minds, as they work together. And so we'll talk more about that. But just to jump in, here are some example questions that would be tied into this idea of addition as like, adding like terms, like counts, looking for common terms, right? So that we can combine them. So, and hopefully this is going to stir up some creativity with your learners, and they're going to be thinking in ways that maybe they haven't had before, and giving them permission to be creative and to work with their partner to engage and have a good conversation. And so this board, just really quickly, this board should be a collaborative effort between the two of them. So it's not just one. It's not just one who's doing the work on their own, and the other one just kind of sitting back. But they are working together. And so this board should be a collaboration of the work that they're doing together. They should both be agreeing and following each other, even as one has the marker, right? And so so it should be a lot of fun for them. I think they'll enjoy it. So this first one, and again, I would probably give them more questions than they would have time to do, and I would start off with some simpler ones to make it more accessible for students, but definitely put in some challenging ones and like mix them up. Don't just save all the challenging ones for the end, but put some in there and let them choose. Let them kind of go in there and see which ones they want to try. So so this first one, 3 twos and 9 twos, and I would just have them jump in here. You know, I might have them identify the terms maybe the first time we do it, or maybe some of them identify the terms, some not. Maybe you could have 2 sections or something. But I'm just going to go in and work on the counts here, okay? So 3 twos and 9 twos. I see they're both counting twos. So we can keep the count of twos. And 3 plus 9 gives us 12. So we have 12 twos, which is the same as 24. Okay. This next one, we've got 5 thirds and 13 thirds. Again, we already have a common count of thirds. So we can keep that we can keep the count of thirds, and we simply combine how many we have. We've got 5 and 13, which is 18. And so now we've got a great simple expression for them to simplify. 18 thirds. How are they with fractions, right? 18 thirds. So how many thirds make a whole? How many thirds make a whole? 3. 3 thirds make a whole. So they know that. We always want to start with what they know, right? 3 thirds make a whole. So how many thirds would it take to make 2 wholes? If 3 thirds make a whole, how many thirds would it take to make 2 wholes? Well, that would be 6, right? We would need twice as many thirds, okay? Well, what about if we wanted 3 wholes? How many thirds would it take to make 3 wholes? Right? Well, 3 thirds make 1, 6 thirds make 2. We need 9 thirds because we need another group of 3 to get an additional whole. And then we see 9 thirds makes 3, so 18 thirds, that's double. So 18 thirds would make double that, right? So it would be 6. That's our final answer. 18 thirds makes 6 wholes, okay? All right, 3 hours and 12 minutes. And again, I'd encourage your learners, have them jump around. So not necessarily doing these in order. Probably not going to have time to do them all, right? 3 hours and 12 minutes. Not like terms. We've got hours, we've got minutes, okay? So we want to get them to become like terms, so we can either go hours or we can go minutes, right? We could even go seconds. That'd be quite a bit more calculating, but they could totally do that, right? So so if we go, I'm going to go minutes, right? So I know that 1 hour is the same as 60 minutes. So I'm replacing hours with 60 minutes because 1 hour, that's an equal trade. 1 hour is 60 minutes. And then I've got 12 minutes. All right, so this is 180 minutes plus 12 minutes now they're minutes, they're like terms, they're counting the same thing, and so that would be 192 minutes. Okay. Again, we could also go to hours, right? This would be a minute is 1/60th of an hour. So this would be 12 1/60ths. Okay, that would be a good thing for them to think through. If we have 12 1/60ths, right? So I believe that would be 3 1/5 hours if we wanted to go that route. Okay, so either way. Seconds would be crazy, but they could do it. Okay, next one, 5 square root of 3 plus negative 3 square, 15 square root of 6 plus negative 3 square root of 6. Again, counting the same thing. We have square root of 6's, so we're simply combining the counts in front of them. 5 and negative 3 gives me 12. So we get 12 square root of 6's. And doing this over and over, see, it doesn't matter what we're counting. It doesn't matter that they're square root of 6's. That square root of 6, that unit, that count is going to stay the same. It doesn't matter if it's x squareds. It doesn't matter if it's the quantity of x squared plus 3. If that's our common count, right? If that's our common count, our common unit, that stays the same, and all we're doing is combining how many we have. This is the idea of addition. So instead of teaching these as different skills, right, we're teaching this broader idea of addition. This is what it looks like to add. It doesn't matter what we're adding. If they're square roots, if they're variables, if they're variables with cubes or fourths, or if they're binomial expressions, right? It doesn't matter. As long as we've got a common count of something, we simply combine how many we have, right? Okay, next one. 19 and negative 5m and 3m. So here we've got 3 terms, and it's good to throw in multiple numbers of terms, right? And so I see here we're counting m's here, we're counting m's here, but this first term we're counting ones or wholes. So that is not a like count. It's not a like unit. So that 19 is going to stay. But these two are counting the same thing. They're counting m's. And if I have negative 5 plus 3, essentially losing 5, have a debt of 5, gaining 3, that would leave me with still at a negative 2. So 19 plus negative 2m, or 19 minus 2m, if you like that as well, right? Either way. Okay. Next one. 8 and 4 of 3 of 2. 8 and 4 of 3 of 2. Again, some students are going to come in here, they're going to see this 8 plus 4, right? And they're going to say 12. But if they recognize these are different counts. This is counting 8 ones. 8 ones. And then we have 4 of 3 of 2. And so now to combine these, we need to get them to be like counts. So we could change them. This first one's counting 1, so we could change this second one to counting 1s, but I just don't think that's very exciting. So I see on the second term, I see right now it's counting 2s. So what we could do is we could change this 8 ones. Let's count 2s instead. Well, 8 ones is the same as 4 2s, right? They're equivalent. And so if I'm counting 2s here, 4 of 3 gives me 12. 4 of 3 of 2 is the same as 12 2s. So now I've got a common count of 2s. 4 and 12 of them is 16. 16 2s gives me 32. Okay. We also could have counted 4s. We could have counted 8s. That would have been fun. We could have called this one 8. 4 times 2, 4 of 2, that's 8. So we could have said this was 3 8s. Right? Now we're counting 8s. So 1 and 3, that would be 4 8s, which is also 32, right? And so it's fun to see different ways, different groups will come up with different possibilities, right? And for them to see that math is actually, there's actually some creativity and there's some choice as to how they want to go. Okay. Okay, next one. 2 and 12 fourths. 2 and 12 1/4. However you'd like to say that. Okay. Again, recognizing this addition sign is separating our terms because this 2 is a count. We're counting ones or wholes, right? So it's 2 ones plus 12 fourths. Okay. So this would be kind of fun. We could count twos. We could count twos. So like if we switch these around, right, we could do this. This 12 we could break apart into smaller factors, right? Into smaller counts, right? So this would be 2 times 6 times a fourth. So we could do 1 of 2 plus 6 of a fourth of 2. Okay, and so we've got 1 2 plus 6 fourths. This turns into 6 fourths twos. Okay, this one's getting a little gritty here, right? If I'm counting twos, then I would have 1 and 6 fourths twos. Well, 6 fourths we might want to simplify that a little bit. So this would be 1 2 plus 3 halves twos. So I've got a whole, and then I've got 3 halves. Well, 3 halves is 1 1/2, right? It's 1 1/2. So this is now 2 1/2 twos. 2 1/2 twos, or we could say this is if this is 3 halves, 2 would be 1 would be 2 halves. So we get 5 halves of 2. 5 halves of 2. 5 halves of 2. Right? That's our count. And so we can separate this. We'll talk about this a little bit more later down the road as well. But we could say this is now 5 halves of 2. 5 halves of 2. And half of 2 is 1. Half of 2 is 1. So this is 5 ones right here, which is simply 5. Okay. We could have done that. We could have also just simply, right? They could have maybe they see 12 1/4. Maybe they're able to calculate that as 3, and so go 2 plus 3. Nothing wrong with that at all, right? Because they're working through these, identifying them as separate terms, separate counts, finding a like count. Okay, last one on this side, 21a and 13b and negative 7a and 6b. Again, these are different terms. Looking for like terms. I'm counting a's here in this first term. I'm counting a's in the third term. So 21a and negative 7a. 21 and negative 7 would give me 14. So it's 14a. And then 13b and 6b. Those are counting the same thing. They're counting b, so that's 19b. And there we are. Okay? Just a couple more. This is how we do, right? We're like, just a couple more, and it's a whole board. Okay. Here we've got 7 square root of x, the quantity x plus 3, plus 11 square root of x plus 3. These are both counting square roots of x plus 3. See, it doesn't matter. As long as they have a common count, it doesn't matter what kind of form that common count is in. We simply combine how many we have. 7 plus 11 is 18. So it's 18 square root of x plus 3's. We've got 18 of them. We've got some value called square root of x plus 3, and we have 18 of them. Okay? 6 nickels and 4 dimes. 6 nickels and 4 dimes. These are not common units. Students they'll tell you that, right? But then they go to other things that aren't like terms, aren't like units, and they try to add them together, right? But they can very clearly see it here. So let's try to bridge that gap for them, build that bridge for them. Okay? So nickels and dimes. Well, I see nickels, right? Well, it takes 2 nickels. 2 nickels gives us 10 cents, right? So 6 nickels. We could take out, it takes 2 nickels for a dime, right? So if I call this 3 of 2 nickels and 4 dimes, now I can call this 1 dime plus 4 dimes. So I've got 3 dimes and 4 dimes, which is 7 dimes. Okay? And you know, if they can work through this pretty quickly, right, and say, oh, 6 nickels, okay, that's 3 dimes, right? That's okay. So like they don't have to do like this direct substitution on that, but it's good to see, right? But as long if they're articulating and they have enough on the board, and if you ask them, that they can reproduce their thinking. Okay. Okay. Next one, 4 of 2 tenths. Remember, these are tenths. 4 of 2 tenths and 2 of 4 tenths. Again, looking for terms. This first term, this is our second term. And so if you read it out loud, you might hear tenths. 4 of 2 tenths and 2 of 4 tenths. That could potentially be our common count, right? So this is 4 of 2 tenths, and this is 2 of 4 tenths. We could count 4s, we can count 2s, we can count tenths. Okay. Here we would get 8 tenths, 8 1/10ths. Here we would also get 8 1/10ths. We're counting tenths. We have 8 and 8 of them, so now we have 16 tenths. And we could write that as 16. We could keep it 16 tenths if you want them to work back to decimal, right? Then you might have them consider, okay, so this is 10 tenths plus 6 tenths. 10 tenths is a whole. 6 tenths we can also write back as a decimal. 6 tenths, 1 and 6 tenths. So how you have them write it as a final answer, you know, you can think through that, what you're going for, okay? 5 thirds and 13 thirds, common count of thirds. So we're just combining our counts. So we get 18 thirds. Oh, and look right here. This is a nice little fraction. We get to simplify. Again, 18 thirds, okay? So let's talk them through. What do they know? How many thirds make a whole? How many thirds make a whole? Sorry, guys. I'm gonna do another color to hide in here. Okay, so 3 thirds, right? 3 thirds is a whole. So how many thirds makes 2 wholes? Well, I need double, right? So to make 2 wholes, we need 6. And if we're talking 18 thirds, and they may need you to keep going as you're practicing this, right? So what if we needed 3 wholes? How many thirds is that? Right? Well, that's 9 thirds. And if we have 18 thirds is double. So that would be double this 3. So 18 thirds is 6. Okay? But walk them through this. How to deal with these fractions. How to take fraction values of numbers. It's really, really helpful, really good. Okay? Next one, -4 of 2x plus 1 plus 12 of 2x plus 1. We have common counts of 2x plus 1, so we combine the counts in front. -4 and 12 is positive 8. So this is 8 of the quantity 2x plus 1. Again, you could have them distribute if you want to, or you could have them just leave it here if you're focusing on those counts. 16x squared, that's a term of 2x, and -5x and 3x squared. I'm counting x squareds on the first and last term. 16 and 3, that's 19x squared. These middle terms are like terms. They're counting the same thing. They have the same count. They're counting x's. Positive 2x and -5x. That would leave us with plus -3x or minus 3x, however you'd like them to write it. -22 and 11 fourths and 11. -22 and 11 fourths and 11. They could do a common count on a couple of them and then kind of see where they are and then pull in the third term, or they might see, do all 3 of them have a common count, right? What if we went for 11s? -22 is -2 11s. 11 fours is the same as 4 11s. and this is 1 11. So if you look at them as counting 11s, negative 2 and 4 is 2 11s, and then one more would be 3 11s, which would give us a total of 33, right? This is so much richer, in my opinion, than simply telling them to do order of operations, right? They're thinking factors, they're looking for common terms, thinking different ways they can combine. Okay, 3 of 2n plus 12n plus 4p. 3 of 2n plus 12n plus 4p. I see n's, but this one is counting 2 n's, and the middle one is counting n's, okay? So we either need to get the count to be an amount of n's, or we need to change this middle one to 2 n's. We could do it either way, right? We could call this 6n, 6n, and 12n would be 18n. Nothing wrong with that. Just for fun, we could do 3 of 2n plus 6 of 2n plus 4p, right? So now we're counting 2 n's. And we get 9 of 2 n's plus 4p. 9 of 2 n's would be 18n plus 4p. Okay. And again, we could have just said this was 6n and combine it because we're counting n's. Okay. All right. Last three. 8 of 3 plus 5 of 2 to the third power. 8 of 3 plus 5 times 2 to the third power. I think we were discussing this a little bit, that this may be difficult, and if this is too high, that you know it's going to be too high for your learners, right? You could simply take off if it's the cube that's going to bother them, you could take off the cube, right? If you haven't gotten into exponents much at all. But if you have, right, we could do a couple of things here. We could, if we think of what a cube is, right, this means 2 cubed. 2 cubed is 2 times 2 times 2, which is what? It's 8, right? 2 times 2 times 2. So one thing we could do, right, is we could say this is 8 thirds. Actually, let me go and switch this around. Let's call this 3 eighths plus 5 eighths. And now we're counting eighths, because 2 cubed is 8. So 3 and 5 gives us 8, and we're counting eighths. 8 eighths is 64. Okay. We also could have turned the 8 to a 2 cubed, and we could have counted 2 cubes. 3 and 5 would give us 8, so we would have had 8 2 cubes, and then simplify. Okay. Last one. 5 of m minus 3 plus 5 of m minus 5 of m minus 3 plus m of m minus 3. This should look a little familiar. Factor by grouping, what your students are going to have to get to when they get into trinomials, right? And so if they can recognize, right, common count right here, what we do is we add together how many we have. M minus 3, because there are times in algebra where we don't actually distribute. We don't want to distribute when we're factoring. We're looking for counts. We're looking to put things together like that, but we don't want to distribute. And so if we can encourage our learners sometimes, right, is let's keep it together as a single count, and let's compare it to another count instead of distributing and making more terms, right? Let's keep this as compact as possible with the number of terms. So here, if we're counting m minus 3, we're going to combine the numbers in front, and this is probably going to be pretty challenging for them. So, like, you might even consider doing some where you've got a number in front here, like, you know, maybe a 7. So it would be 5 plus 7 m minus 3s, right? Where we're adding, because we're going to add these counts together. But this could be a really good conversation, right? This count in front is going to be 5 and m, because we've got a common count of m minus 3s, and we're going to combine the amount that we have. We have 5 of them here, and then we're gaining m amount of them here. So this simplifies into 5 plus m, 5 and m, of or times the quantity m losing 3. M losing 3, which is, we need this for higher levels of algebra, right? To be able to factor expressions when we're needing to simplify, when we're needing to find zeros, when we're looking to solve quadratics, that sort of thing. So it'd be really helpful. So I hope this was fun and encouraging for you, and shoot me a line. I'd love to see if you tried a few of these and found something a little more creative in terms of going for a common account. Talk to you soon.